Again, thank you so much. The group may not know. We spoke and we were speaking about Searle stuff. And when you mentioned the work that we're doubting, that presentation was something that I actually asked if you could deliver. And in the future, if you're open to it, I would love to have you talk about Searle more as well, because again, you've been on the Searle team, you knew him well, you know that work. We've had, I'm not sure if you've seen it, we've had other presenters here who have talked about Searle. And it is interesting that pretty much everyone who has done a serious attempt at an SEG has seen results, right? So
some anomalous, exotic results, something.
Yeah. You know, which is strange because I mean, from my perspective, there are a lot of reasons to think that the Searle effect wouldn't work, so to speak. But even people who have gone into it from a critical perspective, everyone who has really put effort into it has seen something, and many have been surprised. So,
exactly. Okay, why not go for another step? So let's see what else we can do by pursuing it even further.
We have about half an hour for Q&A, so I would love to open it up and see who. Let me see. Allow participants to unmute themselves. I got that, and then so who would like to ask questions? Would anyone like to raise their hands? Chat.
Yeah, I had a quick question, a couple of them. This is Alex. The first was about the mass energy equivalency. I'm not sure if I heard you right, but I thought you said something like, well, mass and energy are not equivalent or can't be converted. I guess the first question is, what is a nuclear weapon, but converting the mass of a fissionable material into energy? That would be the first question.
Yeah, mass and energy do not literally interchange, but it can be fragmented and releasing the amount of energy that is already contained in the matter. So it's not turning the mass to energy, but rather turning it into atomized shrapnel, which is expending its energy so violently that it creates a nuclear reaction. But the energy mass does not become the energy process.
So the second question was about time dilation. I guess so the first would be, you know, when muons come down from the upper atmosphere, you know, they quit, you know, the clock goes at a slower rate due to special relativity. And, you know, I just don't see how the theory would account for that. And then the second part of that would be GPS satellites both adjust for special and general relativity. So without those two, we wouldn't have GPS working. So how does that fit into the theory you presented today? Does that account for both of those changes we use to adjust GPS in our satellites?
Yes, it absolutely does apply. And a man who helped develop GPS for 50 years, a man named Ron Hatch, he's listed on the gps.gov website. He wrote a book, actually, hold on a second here.
And, you know, if I could jump in really quick while Jason's doing that, someone in chat, a fellow named Ross Small, had actually is actually talking about the exact same thing in chat. So it might be worth looking at that as well.
So Ron Hatch wrote this book called Escape from Einstein, where he detailed how GPS has nothing to do with relativity, but rather has to do with the re-emissions from different frames of reference in different potentials of gravity. But Ron Hatch used a distorting ether media to say that the frequencies are deforming in one area and then are different in another. So there is a lag, but really it has to do with the electrons making up the source. The information transmitted to the ground is not dilated at all, but the electrons making up the apparatus are undulating, depending, or not undulating, but rather are deforming dependent upon the gravity, and the information transmitted is not the same as the deformation of the electrons. So they see the deformation and they assume that it is associated with reality and time itself. So there, all of this is in great detail in some of these. So if I'm not doing it justice, go into the document and you can see all of the equations and different approach for that to really do the GPS claim justice.
Great, thank you so much, and thanks for the book reference.
Absolutely.
Okay, and let me see. Matthias had a question. Matthias, he was asking about inertial forces in the craft with the bubble that isolates. Let me see.
Yeah.
If I
So in
Yeah,
you know, actually, Matthias, before you go, if I could ask yourself and everyone to turn on your cameras, especially when you're asking questions, and that way we can see and interact with people better. And Mark mentioned that as a reminder, and I should remind as well. So if you're able to, please turn the camera on. Thank you.
here I am.
Thank you, sir.
Yes, Jason, did you understand my question?
no, I didn't get the question. It was reiterated by Tim, but I didn't get the
Yeah,
full-
okay. The thing is, when you have a bubble, regardless if you call it a warp bubble or whatever, my understanding is that it sort of isolates you to the rest of the universe when you travel.
Well, it isolates you from the
Inertial
of the
forces.
matter of the, but you're still within the same universe.
Yeah, I know, but in a craft, for example, an IGV, if you were to do 180-degree turns, would you be crushed?
No, it would be as if you're sitting in your chair right now or sitting in
Yeah, that's also what I believe is what's going to happen. But when I listen to your presentation, I sort of think, what isolates you from the inertial forces? Then what saves you from being crushed by the walls?
That would be the emissions of gravity from the electrons making up the craft itself, being emitted at a different wavelength or frequency, which competes with the surrounding environment.
Okay. I have another question. You're aware that I think the last page, or the page before the last, where you had a picture of Professor Searle, are you aware that the picture from the book, from one of his books, is actually from Potter?
Paul Potter?
Yes. You see the maypole effect.
Yes.
Yeah, that is from Potter.
And then John
His interpretation of the Searle effect.
and then Searle used that in his as an
and you were saying recently in a Facebook post that you don't really believe in the breaking of the magnetic reconnection.
Yeah, because there are no magnetic field lines. There is an overall drop off and a gradient. Like there is no candlelight lines for the luminosity around the brightness glowing to a candle. There's no electric field lines. There is a gradient of potential. So when you put magnet filings on a paper and you see that is lining up with the gradient. The particles are aligning within the gradient, but there are no field lines themselves.
Yeah, I just wanted to make you, to point out that it's actually from Potter, which you disagree with.
No,
yeah, okay. I have no further question at the moment.
Thank you, Matthias. So let me go to Jeremy Reese, sir.
My favorite. Yay.
Hey Jason, I was hoping you would have talked more about your work for Searle and with Russell Anderson and those guys and what you did there. I'm still curious about the research that you guys did into anti-gravity and weight loss and if you could talk a bit about that for first.
Yeah, we have not directly measured any weight loss because that is the higher level experimentation that requires more funding to get to that point. But other people like the Paul Murad Morningstar group and other guys, they have alleged to find weight loss with given RPM and transient tests. But we have not measured any weight loss yet because we're still in the research and development phase to generate the electron emissions. But we, over the last couple years, or last year and a half, really, we have made incredible leaps and strides in the magnetization. So now we have a huge grasp on that. But in order to provide the higher level validations, that requires the 3 mil to put it all together. So that's kind of the financial paradox we're in. So in order to validate that stuff, we need the funding. But in order to get the funding, we need to validate it first. So we haven't measured the weight loss, but we will eventually once we get to that level.
You know, Jason, if I could jump in real quick,
Yeah.
you mentioned the striping on the rollers. And so when I talked to Paul Murad, he was, we were talking about the Morningstar device. I did an interview with him, and he had said that at first they didn't stripe their rollers, but they left the device sitting in a specific position, right? So that the rollers were at an angle, and so they picked up kind of their own magnetism. But they didn't do the Searle style striping. I guess they did some embedding of mini magnets in them. But
yeah, we don't do any striping, but we just do layering. We have solid state materials, the neodymium core, the Teflon dielectric, the proprietary magnetic material, and the OFHC copper. And
Yeah.
those are solid state. So if you want to consider that striping as the layered effect.
Well, what interested me though was Searle had, and again, I don't have your expertise in this, but Searle had talked about, he had talked about some magnetized striping on the rollers themselves that acted like magnetic gears, basically.
Right.
And what did intrigue me was when Paul was describing this, what Paul had told me was he didn't think that was necessary initially, but during testing, what they found was when they let the machine sit, right, where it naturally picked up a little bit of this, it kind of created its own striping. It led him to believe, and this, what he told me was, he now understood why Searle would stripe those. He said, and that intrigued me when you mentioned that, because again, the Searle effect, for me, I've always approached it from, it was always difficult for me to accept the Searle effect, I guess. But what does intrigue me is that every attempt seems to validate at least some part of it, you know? So.
Correct.
Yeah. So.
Oh, and to finish Jeremy's thing about the, the other conflicts, we can talk about some of that privately. I'll answer all the questions you want.
Yeah, I'm definitely curious to know more about that, because I know that you'd gotten some funding before and that you were working, and I saw a bunch of posts a while back about some of the work you were doing, and I was just curious about more about. You said 3 million. That's what you need now to finish your research.
Yeah, over the course of 18 months to full-time, 2 years full-time work. So that money will be used for hiring personnel in specific areas, and then to update some of the equipment, and then account for unaccounted for problems and everything we could possibly need. And that's pretty much undervaluing the
That's yeah, and that sounds like a lot, but again, I think the Morningstar one was pushing 1 million, and
I'm hoping all this cryptocurrency and AMC folks is going to help out. Maybe we could get some funding from some newly made millionaires, please.
Well, let me go to Michael Richardson. Michael, sir. Oh, and you're still muted. I'm sorry.
Hello. I've worked with some of John Searle's old team in the UK. John left us with a doubt whether his technology was real. Yet he flew this technology in the UK, and yet we still don't have any historical data to back up any claim from John Searle whatsoever. And only 2 days ago, I was working with some people working on an SEG in North London, and no results whatsoever for anti-gravity lift, negative lift, no weight reductions or anything like that. So we're not getting any results whatsoever. And we haven't found anyone who can replicate the old Searle technology, and Searle himself seems to have a problem to replicate what he started in the beginning. Do you have any doubt in John Searle? Do you have any doubt in the mission that you're trying to accomplish?
Not after working directly with him for so long. and validating his claims step by step and isolating them out in materials and things that we build to isolate his claims and work it out. Everything that we have done has validated his claims, but in order to make things lift, you're talking millions of dollars worth of support and work. John Searle never manufactured the parts by himself, and that's a misnomer that a lot of people have. He was working at the industrial electric plant, and he gave the.
It's just that the Russian.
Yeah, well, he never built the parts himself. He had other people make the parts for him. Then he brought those parts home and assembled them and tested it, and it worked. But the Russians, they had a facility, they had funding, and they were also trying to duplicate his claims. The BBC claims to have master footage of an episode of his Levity disc from the late 60s. I have the master code file, which is alleged to be in their archive. But around 2008, when I tried to get that footage from them, they said it's listed to be there, but they can't find the footage. But it is in their list of material that they do have pieces done. They did weekly pieces on John Searle for over a year, of filming him every week. So that footage exists, but not with us.
Do you know that John Searle is not an academic professor? He was granted professorship from a German
an honorary professorship from Zurich.
Okay, so scientifically, how do you find the scientific data when John is talking about the theory of the squares? Do you see a direct connection between the theory of the squares and what the effects of the SEG are trying to achieve?
Absolutely. You cannot build the SEG without the knowledge of the squares, and that is how it is done, because it determines the quantities and the variables of the materials that you need in specific orders. And without that understanding, you're just going to make a paperweight, and you're going to doubt and flounder. And that's what everybody has done. And that's the most difficult thing for me to understand, was his law of squares. And I'm still trying to grasp it. But now we have an understanding of exactly how to use it as a calculator and a spreadsheet. So it is extremely valid. And that is how we build the materials to the exact specifications needed.
And the law of squares, it's used in the Rodin coil vortex-based mathematics a lot too, right?
That is a completely different approach and explanation that doesn't have to do with.
I'm just talking about the mathematic coding of the actual magic square.
There are differences.
Mathematic sequences, though.
You can reuse numbers in Rodin's approach, but you can only use the same number once, like in Sudoku with Searle's method.
Let me go to let me go back to, or actually let me go to Will Riken. Will, let me go to you next, sir. Okay.
Okay. So I went looking at your presentation. So are you saying that, you know, in the overall of your presentation, I get the opinion that you're saying that AC and DC energy doesn't really exist, except that they're apparitions of each other, some reflection of each other, or?
No, but rather the light, the primary emission, whether it be light, whether it be gravity or electromagnetic radiation, it's not the same light or gravity or radiation that propagates through things, through media. At every point of interference, it is a brand new re-emitted packet. So it's there's AC, there's DC, there's all of that is very valid. But the consequence in all frames of reference is an assumption under relativity. So a sphere expands from the source, but if the source is moving, the sphere is still expanding relative to that source. So Maxwell's equations from the source, but a Maxwell equation does not mean that it has to have a constancy in all frames of reference. So that's the difference.
So you're just stating that you, so what you're really saying is that what begins is not what returns.
Correct. It is never the same packet. And you can never, no observer ever sees a primary packet. It's always a re-emitted secondary.
Oh, okay. I just wanted to understand it better. Thank you.
Thank you, Will. Let me go back to, you know what? Let me go back to Matthias. Matthias?
Yeah, Jason. Did you ever talk to Peter Searle, his brother?
No, but I know they had conflict.
Oh, indeed, they. I can now when John Searle has passed, I can tell you one of the things that John did to Peter. Do you want to hear it?
Well, we can talk about that.
Yeah,
okay.
that might be a little bit too.
Yeah. Okay, so but Peter Searle claimed that they could never control the SCGs in the 60s. And I assume that the Demo 1 was an attempt to control it, to make sure that it didn't just shoot out into space immediately when you sped it up. How do you, I mean, what's your thought on that? And how do you propose, or have you had any idea how to control it so it doesn't just shoot up into space?
That's when John Searle incorporated the dielectric layer. He never had the nylon 66, which now we are replacing with Teflon, but he never had that dielectric layer before. So every time he tried to extract energy or with a load, it would overload immediately. It would have no control. It would be like a dam, a reservoir with no wall of a dam. So every time you try to draw a load, you just get this huge overflow and wave that takes out the whole system.
Yeah,
So
that seems reasonable. Yeah.
With that dielectric layer, it holds it back, creating a
resistance, right?
Not a resistance, but rather a method of a re-emission for a carrier. So it re-emits the energy. The energy propagates like light, and light can pass through insulators. So without that insulator, it would overflow. So it regulates it.
I'm just curious. Did you ever measure the kick on roller segments?
What do you mean by the kick? The torque is proportional to the load put on it.
No. When I was when I went to a seminar in March '96 with John Searle, he had an oscilloscope and a small rotor segment. It was not magnetized, and I was told that I can measure a tiny voltage being, created by the roller segment.
Because rollers are a semiconductor. They're not just, the magnets are also a semiconductor.
Yeah, but it wasn't magnetized at all.
Yeah, you still get a voltage. You can see a voltage differential between the core and the outer.
Yeah, but when you took the oscilloscope probe and you discharge it, you saw the pulse on the oscilloscope, and then you had to wait a few seconds, and then you can get a new pulse from the roller segment.
Almost like it's almost like an electret.
Yeah, but electric usually needs to be programmed with a high voltage when it sets. And I think that the insulator in that segment was probably, I'm not sure if it was nylon or if it was PTFE, but with PTFE you can't do that. I mean, it's not a thermoplastic in the terrestrial sense.
Different dynamic to it.
Yeah.
Yeah.
Okay. Yeah.
Well, thank you, Matthias.
I'd like to answer.
Oh yeah. We've got about 6 minutes left. So
let's go with Michael Boyd. He's had his hand up for a while.
And Michael, sir.
Can you hear me?
Yes.
Yeah. Yes.
So I'm kind of curious. I heard you say something to the effect that time is a constant metric. Would
Time
that
is
be
a
correct?
constant. It is absolute no matter what.
Well,
To
in
everyone.
that model, right? In that
In
model.
that
Yeah.
particular model, yeah.
Okay, and then you cited, as I remember, you were citing the cesium clock for an example of what you were talking about. Is that correct too?
Correct. The cesium atoms, the electrons around the atoms actually deform depending on their exposure to a strength of gravity and the potential gradient.
But they have a constant decay rate too. Is that the?
No, they are, depending on their exposure to gravity, they will decay faster or slower, depending upon their gravitational influence. And then if you judge the rate of decay and time itself, and you think that the rate of decay is always the same, regardless of altitude, then you will have a false impression of time because you're judging time itself by the rate of decay. And that's what the error is, even though that the information.
So you're saying the rate of decay is independent from the time?
Absolutely. Like two apples can decompose at two different rates within the same reality. Two different cesium atoms can decompose at different rates within the same reality. But if you judge reality itself by their decay rates, you'd think that this decay rate is different reality than that one.
Okay, well, I'm curious about the decay rate because of there's some evidence that a coronal mass ejection will produce a reduction in the decay rate of certain radioisotopes on the opposite side of the Earth from the sun, a day to a day and a half before the coronal mass ejection occurs.
That is interesting. I had not heard that. So I can't give an opinion on that one.
Yeah. Well, let me, if it's okay, let me go to Jay really quick. And Michael, I'm sorry for cutting you off, but we're pushing up against the wall in terms of time. So Jay, sir.
Thank you. Jason,
could
first of
you
all,
turn your camera on if it's okay?
oh, and I apologize. I actually don't have a camera. I'm using my desktop.
Okay, no
Next time
worries.
I'll use my laptop. But Jason, thank you so much, first of all, for always being able to explain things in layman terms so that people like me can actually follow and understand. But my question to you is, the one thing that I'm having a hard time understanding is you were saying with regards to light propagating at the speed of light, it depends on also the speed of the source of the emission. But what I'm not understanding is how is it that if a sun, for example, that's 10 light years away, if it explodes, disappears, you'll see it in real time, but at the same time, light propagates at a certain speed, plus whatever the source of the emission at the speed of the emission is. How do you reconcile that? That's the thing that I'm not really understanding.
Well, according to Huygens principle and according to the Galiliean transformations, every source has its emissions. The emissions propagate at the speed of light from the source, so c, relative from the source. But if the source is moving towards you, c plus the velocity of the source, so c plus v. If it's receding away from you, c minus v. So the electrons making up yourself absorb that primary. So no matter how fast it is coming in, the electrons making up yourself will absorb it and then re-emit it at the rate of c. So you can never measure the velocity of anything other than your own re-emission, serving the illusion that it's always the same to everybody. So it's reconciled because the electrons making up everybody and all observers extinguishes that primary no matter how fast it is, and you can only measure the secondary.
Excuse me. Okay, so let me give an analogy just so that maybe you could understand where my misunderstanding is coming from, and then maybe you could correct me. So it's a little crass, but just layman terms, right? If I had a broomstick that was a light year long, right, and I moved that broomstick up 1 foot with my hand, it wouldn't take the other end of the broomstick to go up 1 foot, right? It would go up instantaneously.
Well, now you're talking about an object connected to it, but a wave packet does not behave like a physical matter.
So that's where the confusion is coming from, because from what I understand, light isn't like this rigid body like the broomstick is, right?
No,
so so a rigid body, you'd move up 1 foot and instantaneously the other end of the stick, even though it's a light year long, it would move up one foot. But if there is a sun that was a light year away and it disappeared, how if light travels at a constant speed plus the speed of the source, how would that information reach our eyeballs instantaneously, like the broomstick?
Because everything you're already looking at, everything that's already illuminated, you're looking at in real time. Light is not a recording of reality that hosts information. What you glean from what you look at is dependent upon what you have already experienced and learned before. Two people can look at the same thing and one of them can get more information than another because the information doesn't propagate.
Okay, well, so Jay, let me meet you out. You know what? Let's do one more. We'll do format, who has been patiently waiting, and then we need to move on to Mike. But okay, and what I would say is, we do have an open discussion later. So if you want to pop back in, I should mention that as well. But let me go to format really quick, sir or ma'am. I'm not sure.
They.
Howdy, sir, I suppose, not quite sir age yet, but I was wondering, Jason. Oh wait, actually, can you guys hear me fine? This is my first time.
Yeah,
cool, excellent. So you were saying if a craft of a certain type flies into an object bigger than itself, the craft will be displaced, while smaller objects will be displaced by the craft. So how is a big chunk of water different from a big chunk of rock when interacting with such a craft?
Because you're dealing with molecules that are cohered together. So every molecule is being able to be flexible and move like a fluid against the other parts of the media. So you're not talking about one dense body. You're talking about just the boundary at the skin of the craft itself. So it would equate it to like an exotic Leidenfrost effect, where it's just at the skin of the craft, and it's just pushing away the molecules at the skin of the craft. You don't have to deal with the entire.
Gotcha. Okay.
Well, thank you, format. Okay,
Thank you.
so let me. I know that we have more questions, and hopefully, possibly,
I'm
Jason,
available at any time. People can have private conversations with me. I'll give you the links, give you all this
Yeah,
stuff.
actually, if you'd like to put your contact info into the chat, I would say type that in. I just don't want to make Mike Gamble wait, who has been,
right.
And so, but let's do this. I'm going to mute everyone out. Okay, and we'll go to Gal Review. And everyone, please, again, a giant thank you for Jason Verbelli. And yes, so Jason's put in his information in chat, and we also, again, we have an open discussion later. You don't have to come, but again, thank you so much for that tremendous presentation.